we are presenting Crosswork Hierarchical Controller, the API to your network. With me, I have my partner in crime, Jona. And yeah, we've been I've been working with this for quite some time now, and I mean, you know, the HCO or the hierarchical controller is kind of the new kid on the block. So whatever we do, whatever we present to you right now, it's like pretty fresh still, right? And let us know if what we do here makes sense for you, if you want to see a change in the session or whatever. So as Omar said in the beginning, give us feedback if you want to see something different. I'm Daniel. I'm working here in the Swedish CX organization as an architect, covering SP customers within EMER, and have been doing so for the past 10 years. And yeah, that's, I guess, all you need to know about me. Right, so what are we going to talk about? We'll give you just a brief intro to what is HCO or CHCO, the hierarchical controller. It's a bit of a recap of what Muti has been telling you earlier today. Then we'll switch from slides to the first glance at the UI. So we'll just have a quick walkthrough of the UI. What can you do? And then Jona is going to run the kind of core of this session, which will focus on SHQL, so the hierarchical query language that comes with HCO, and will make you from zero to hero. And then once you have the foundation of SHQL in the theory part, we will switch back to the UI, where we have the SHQL query app, where we will show you some things you can do. And also we will show you how you can interact with the API of the SHQL. So there are different means to interact with it. We have for example, there's an NSO net that can talk to the SHQL API. So we'll show you a couple of things there, how you can interact with it. And then we'll wrap it up. So what is a CHCO? So C, obviously, crosswork, right? H, hierarchical, and CO, controller. There are tons of pictures that show you where the architectural placement of HCO is, and you've seen it earlier in Muti's session. So HCO is a supercontroller, a top-level controller, a controller of controllers, whatever you want to call it. It's a hierarchical controller intended to talk to controllers that are in charge of the domain. Now, why did I choose this kind of representation of the placement of HCO? Yes, because it talks about models. And models is something that, or the model is something that you will hear me talk about quite a lot, and we will have quite an emphasis on that. Why? Well, the kind of power of HCO is its model. It's the database that yields all that that information. And this is why it's the core of HCO, right? And then we have all the logic, the algorithms that you can apply to it. But it's a database that yields a lot of data that represents your network. So yeah, and I think you've seen this one. So it is a multi-vendor, multi-domain, multi-layer hierarchical controller, and yeah, this is what we see at customer ecosystems, right? So we know this stuff works also with third party. Right. So as we said, it's multi-domain, multi-layer. So we can ingest through different data sources, either directly talking to another SDN controller, or could also be an adapter talking to devices, ingest data from your network, so optical domain, IP transport domain, microwave, whatever. And we feed that into the brains, which is the model, the database that represents your network and the state of your network. And this is then when we can do all that correlation stuff, right? We can tell you at one point, once we have sucked it all up, like, okay, you have an LSP. This LSP is using this IGP link. This IGP link is using those links between those optical links, and that's how we can give you the view from the service to really the fiber that is in the ground. Yeah. Again, this is the model of HCO. So we go from physical up to yeah, the service that you transport over that, and this is basically what will end up in the database model as well. It's also a slide shown earlier today in Muti's session. But yeah, this is what it is all about. This is the database that you can then ask your questions that you have, either going back going back in time, or doing root cause analysis, asking questions that are really complex. And Jona is going to talk us through how we do that with SHQL. The model itself is something that we can't really influence as a CX or a customer. It's something that comes from the BU, right? So if it needs an extension, like what did we have? Flex Algo, for example, was something that didn't work in version 5.3, which then basically, when we enabled it in our lab, then basically we saw things happening that weren't supposed to happen. But then it was because the model did not know what flex algo was, and so we had to teach the model what is flex algo. Why do you all of a sudden see a difference in the output of the show ISIS database command? And we had to train the model to understand, right, this is flex algo. So if there's anything else, like in addition to the model, this is something that that comes from our BU. Right. That basically is the quick summary of what is HCO, right? It's a hierarchical, multi-layer, multi-domain, multi-vendor controller. It's keeping track. It's an always up-to-date network model, right? Because it's like NSO, it's the source of truth from what is in your network. This thing ingests partially things from NSO as well, because it can ingest things from state from CNC. So what you see in HCO is what you have in your network. It's like a mirror of your network. It's always up to date, or always up to date. There is polling cadences, obviously, that you need to take into consideration, or event-driven stuff that hasn't propagated yet and things like that, but fairly up to date. Oh, right. We did say we would answer questions. So if anybody has a question throughout the presentation, then just raise hands. Yeah, and also no, it was never published, right? The draft, because this was supposed to be a hands-on session as well, but we were asked not to make it hands-on. So we'll see how we'll show stuff on the UI instead, and demo things. But yeah, it would have been cool if we could give you hands-on, but okay. Right, single pane of glass for provisioning things in your network, visualization, and there's also assurance capability. Cool. Let's switch. Where's the browser?
What Daniel will do now, we will open the UI of HCO. This is a demo environment, so what you currently see is not a real network, but it's a stale model. It was built based on different networks that we've seen in our customers. Okay, so no real devices behind it, but you could get a very good concept of what it is.
So oof. So now I don't see it on my laptop. I only see it here. Great. Okay, but it will work anyway. Let's yeah. It doesn't let me. Right. No. Cool. So this is basically the view that you get when you log into to HCO and you choose the Explorer app. That's the default setting. It will bring you there. So here you can see the aggregated topology view of an optical network and an IP transport network. And you can switch between the layers. So you could click this button, for example. It would only show you the IP transport network, or click this one, and it only shows you your optical network. or you go for the combined view, and it will superimpose the IP transport network on top of the optical network. Let's see, we can do things like tags, for example. We could filter on all Cisco stuff, or we could filter on Sienna, or you could do a regional tag that would only display um, devices of a certain region or a certain area. And we will show you how those tags work, because actually it's all SHQL. So Sedona, HCO uses SHQL under the hood for a lot of stuff it does. Right. So now let's do this. So I want to search for a link here. I want to see an SRTE tunnel in this topology, for example. So I click it, and what we can do now here is we can select the path option here, and what this will do, and you can see the visualization of that path here, right? So you see the orange line that basically represents the SRTE tunnel, and then you see the green line that is basically the optical fiber that is used by this SRTE traffic engineering tunnel. And we can click on this path tab over here, and let me just expand this because it's massive. Come on. Yeah. Or not. Right. So this basically drills down from the upper layer. So the upperst layer here is segment routing, because we selected an object of type segment routing traffic engineering tunnel, and then it will like iterate through the different layers all the way down to the lambda that we're using on the optical equipment. Oh, yeah, here. So if you would, for example, have a failure in an upper or in a lower layer than segment routing, and that segment routing tunnel would go down and it would be service affecting, you would be able to see at which level this fault is actually occurring, right? So let's actually select this link. It's a bit jumpy.
Is it just segment routing tunnels that you can see, or does it work as well with RSVP?
Oh, it works with RSVP. So yeah, two things, right? I said the model needs to support it. So if there is a representation for an object in the model, yes, it will be it will be consumed by HCO, and yeah, for RSVP it works as well, not only segment routing. So here you see this fiber is obviously this fiber connection is obviously faulty, and either by SHQL queries or then also by using the UI option here and clicking on the use by, you can iterate through the upper levels and see what is actually affected when this link is down. Now, I picked this link in particular because HCO has a time machine. So this is live right now. So this is the view that we're looking at right now. But let's go back in time. What was the randomly selected time? Okay, thank you, Doc Brown. I will put that in the flux capacitor here. So we're traveling back to May 2nd 11:20. I probably had lunch. May 2nd. Yeah, that was not a day off. Ooh, look, the neighbor link is down as well. What happened there? So you can go back and forth. You can go back and forth. And you can't go into the future, obviously, but you can travel between present and past to look at network states, and you can run root cause analysis against this. This is a very powerful tool, and it's not only available on the UI because everything is basically an SHQL query in HCO. You can do this from a REST call or from whatever you want to use it. You can obviously use the built-in apps. Yeah, we didn't explain this, but obviously here on the left-hand side, these are all the apps that are currently enabled on top of Sedona, on top of the HCO. Damn. And there is also, for example, where is it? I can't see it. That one. The net. Right. We need to leave this one. Let me. Sorry, I didn't catch the question. Can you repeat? Any use case? Tons. I mean, what visibility into your network, like complete visibility into everything? Is that a use case, for example? Okay.
I think one thing is to visualize everything at once. I mean, like if you have the WDM network and you have different controllers and different overviews, this is fantastic. That you see the NOC looking at just one system would be amazing.
Thanks for making the marketing for me. It's selling itself already. It's selling itself already. Right. So let's do a network history query. So example, let's do today. Yeah. So we want to have a look at what happened during the past 9 days. And we want to do, for example, what a link. And we want to have a look at the uppers. Yeah, I did type a dot. It's not letting. I think this is not liking the enlarging the view. Can you see it? I can't. Let me just do this. Just need to refresh the UI. I think it doesn't like the control plus control minus thing. Right. Upper status. And then we want to basically see links that change from up to down. Boom. All the links that changed its state from up to down the past, what is it, 10 days or whatever that is. Pretty cool. Anything you can do today in your network? Not yet? Maybe with this tomorrow? Right. That was another app. SHQL query. That's what we're going to focus on in a bit when Jona took you from 0 to hero in SHQL. Right. I think that will do it as the initial part on the UI. Do we want to highlight anything else? Nope.
Do I see a status? I mean, you see that it went down, but do you see status like light levels and readings from the actual interface from?
Oh, you mean like performance visualization of the throughput,
Like
or?
the interface that went down, right? So I want
Yes.
to see if am I getting light on that port? Do I see any RX values or LX I mean, what is the if I do get light on that port?
Is it part of the?
Yeah, well, there is an application called Link Assurance and Service Assurance, and in that application, you can see the view of your link or your service, and in the let's say optical layer, you can see also the power levels, the queue value of so you can see all the optical and the per each layer, you can see the KPIs that may affect your service. Link assurance, I think it's the yellow one. Yeah, maybe you can show just an example.
Yep. I think we have time.
Choose any link. You can choose or from the tabular view, or you see the tab of the 3D Explorer. You can choose also links from the map view. Seems like Scandinavia is too far away from the VM server.
So
Choose any ID link.
let's take this.
Press OK. Now
I can't see this. This is not really visible on the UI.
press that icon. Yeah. Yes. Choose this line. No.
No.
Already
Yeah,
cancel.
I'm in my own way.
It is 70. So here we'll get kind of a schematic view of the service, or in this case, the link that we've chosen, or not. Oh, it took us back.
That was my bad.
No, this will be.
Yeah. I'll re-add another link.
Choose a ZR
Sorry?
Maybe you can choose any ZR service.
Yeah. But then I need to. Let's take it from the. Let's see. Can we set that in the layer?
Yeah, you can save the layers, filter the layers.
Set R. Is it filtering? No. Set R. I'm not able to see what I'm doing.
Now you see only the ZR links, for example. Choose an ID. Select any row. Now you see. Yeah.
don't see it.
It's a bit challenging looking towards a different direction.
Was it achievements or?
Yeah, so you've chosen the ZR media layer, and you can see that because it's a demo environment, you cannot, we don't have this measurement, but you see it's key margin and the key factor properties and many others. So let's say if we've chosen the Ethernet layer, you could also see utilization, the RX, TX, and so on. So by using this application, you could see actually yes, a layer of your network, whether it's it hits the targets that you assume it will or not.
I would maybe add something. Basically, in such an application, when you have a setup of an optical setup of modems and then amplifiers in between, you will see the full link span at the bottom of
Oh.
the diagram. That means that you will see the OTS links, which are between amplifiers and modems, and then on top the OMS links. You can click on each one of them and get the RX and TX powers both as a summary and as a performance with all the history that was collected on the node.
Thanks for chipping in. Good. Yeah. No, we don't do that now. That that will be kind of another session. I can show it to you later, another time. Where's my mouse? Oh, there. So we did that. Jona, stage is yours.
Hi. So I'm Jonas Schichmanter. I am from a customer experience product management team. Originally came from the Sedona team that we started developing this tool. And I would like to show you the strength of SHQL. Great. So when we started to work on the product, one of our aims was that it will be the only a golden source of your network, meaning that our users, our customers, you will point all your other systems to HCO, and only HCO will actually reach the network itself or the controllers. So in order to reach to that aim, to that goal, we understood that we have to provide a simple way, an easy way for the user, for the customers to query our database, the model. Because the environment that we are working in, which is a complex network, multi-layered, that a lot of different objects are connected to each other in the different layers, right? Connecting pointers up, pointers down, and so on. In order to do that in a regular model, probably you need to be a SQL expert. Most of us are not. So we found a way to simplify these queries that also regular people as me could query pretty complex queries about the network. Okay, so then we came up with the SHQL, which is Sedona Hierarchical Query Language. Okay, so by simplifying everything, it also make the integration with other tools and systems you have in your network. It makes it pretty easy. OSS or any other systems you have, because everything that we will be talking right now, you can send and query through a simple REST API. Okay, guys? So you probably have your teams that are writing in Python, Java, any other language. You can combine it and integrate through a REST API and get everything that you need. So the SHQL let you traverse up and down through the different layers. You can transform from one object to a different one. Let's say you can start, okay, I need the Ethernet link, but I don't actually want the link object itself, but the endpoints. So we can start asking from the links, and the reply will contains only the endpoints of these links. Also a very strong tool that, as Daniel showed us, we can also ask queries about the state of the network in the past. Okay, not only the concurrent status. That's helping us in troubleshooting, if you have any troubleshooting systems. Now, the HCO, as Daniel mentioned, is also being used by our developers, meaning that all the communications of the applications that I just showed you, also the communication of our UI with the database are working through SHQL queries. So also the tags that Daniel was showing you are using SHQL, and SHQL can be worked through a REST API. Daniel also wrote a NSO NED, so that you can use and reach the SHQL in many different ways, whatever suits you best. These are some examples of how the queries might look. You see that it's a straightforward, not too complicated. And now I just want to go through basic rules, and as Daniel called it, from zero to hero. So, as I said, SHQL enables you to query pretty complex queries regarding your network. You can send in API, and all responses will come in a list of JSON objects. In that case, it will be easy for you to translate yourself the data that you're getting. There are many filters, conditions, functions that will help you to pinpoint the tailor-made, the specific information that you need, the specific query that your organization or your system needs. And also, there is a way to manipulate the replies also. You can sort it, ascending, descending, whatever. You can have a view. Let's say every object, every JSON object has a lot of attributes, but you need only 5 attributes. So you can choose whatever to get back in the response. You make it smaller, and it will be much easier for you to parse only whatever you need. And as mentioned, SHQL can be queried through REST API. So let's start with a quick view. This is the SHQL application that Daniel showed you. You open it through the bar, the menu on the left. Actually, you see it very simple. You just start writing. You want an inventory, so you start writing inventory. It's autocomplete. Then it will open a drop list with the next step that you can choose from. And every time it will show you what are your next options in order to have a quick and a complicated query. So you don't have to remember the syntax by heart. Okay? In the application itself, the response will come in a tabular view. You can each one of the rows, of the columns, you can filter, sort, and so on. Another strong thing is that you can also export everything into a file, okay, and take it to other system you need. In this application, you can see that the response is pretty big, and it's being sorted into different types. Meaning we were asking for the full inventory. So we see here a tab for ports, tab for a power supply, tab for a fund trace. Okay, so that will be very easy for you to see whatever objects you have in your inventory network. This is an example of one of the response. It's a JSON object. You see all different attributes that you get, and out of these attributes, you can choose what are your needs in the in the new tool that you're working on. One important attribute that you have through all the objects is the GUID, is the generic unique ID. Each one of the objects in the model have its own unique ID. By using this one, you can get to any specific object that you need in the model. Okay. In the application itself, you can store queries, for multiple usage in the future. You don't have to remember anything by heart. Later on, you can also delete it when you don't need it anymore. So it's a pretty nice editor. So we can use the API, as we said. There is one endpoint that you can post any query as a text in a body. Okay, so it's one endpoint, and the only thing that is being changed is the query itself that you put in the body. Okay, that's also very easy. This is example from Postman. So you see, this is the endpoint. We are sending the query, and we immediately getting the response as a list of JSON objects. This is example of using NSO-NED. So this is how we use the NSO, and this is the reply that we get back. So let's start with the easy part, and slowly we'll make a faster phase. So conditions. SHQL is supporting many different conditions, as you can see. Some are for numerical values, some are for strings combined. You can also search inside arrays, groups, and so on. So how can we use the conditions to filter our information? So you see, in this case, we start with the object that we are looking for, and I open the square brackets. Okay, inside the square brackets, the moment I press the dot, it will bring me the list of the available attributes. And then in this case, we choose vendor equals Cisco. So here you can see all different inventory items that the vendor is Cisco. In this case, you can see that I was playing with the AND or operands. Okay, so we have the links. I want a link layer LSP, and the name contains Milan. Okay, so it brings all links, LSP links that are containing Milan inside. Transformation, water transformation. As I mentioned before, you can start with one object, but what you really want is a response of a different object. So in this example, you can see I'm asking for all LSP links, but I'm interested only in the ports of them. So we get all the IGP ports. Okay. I can also ask in that case, I want all Ethernet ports that are connected to links. Okay, so I will not get all Ethernet ports, but only the ones that are being used currently. So what are the different types of transformations we have? We have the pipe. Pipe is a simple transformation, as we saw in the example. We see it again in a minute. So I start with one object with a link, and then I use the pipe port, and I will get only the ports of the links. We can have a collection using the ampersand. If I'll use the ampersand, we'll have both objects we have the links and the ports. And we can also use a temporary variables that will make our queries shorter and much more readable. So let's see exactly how we do it. So in this case, in this example, you see, I'm asking inventory, bring me all Cisco routers, but in this case, I want only the ports. So you can see here in the response, all different ports that we have on Cisco routers, and we get only the ports. In this example, I was using the ampersand to have more object. So you can see, please bring me all Cisco routers and their sites. So I'm not getting only the sites, but I'm getting also the routers. Okay, two different types of objects in one query. And the last example in this case will be temporary a variable. You can see I am asking, okay, bring me all Cisco routers. Let's call them C. But what I really want to see is also all ports of C and all the sites of C. And in this case, we'll have sites, the routers, and all the ports. Okay? Is it clear, guys? Okay. I see some people nodding with their head, so.
Is the database schema published?
No, it's not published.
So we'll have to rely on completion or something to find out.
At the beginning, yeah, it will be kind of a learning curve, but it's pretty fast because the model eventually is not that complicated. Okay? Let's talk about the different functions we support in SHQL. The functions will help you to run through the model in different directions, go back in time. Let's see how to use it. So in this example, I'm talking about the keyword downward. So you can see I am looking for a link with a specific GUID, but I also want to have all the links downwards in the layer, meaning all the links that are being used that are carry this link. So you see that by the GUID, you see that I'm starting with LSP, and I'm getting all the specific links that are carrying that LSP. Now the same, we can have the upward. I'm starting with a link of OCH. I'm going upward, and I go having all the links that are using that OCH link. Okay, so think all the possible options for you to use it. You can know the specific path, as you saw in the UI by Daniel. You can have a root cause analysis, right? You can find, okay, my LSP is down. Bring me all the links in its path, and let's look who is the blame, who is also down, right? Of course, after having the up and the downwards and upwards, there is the span. So in this example, I'm looking for a link Ethernet, but please bring me all the links downwards and upwards. And again, you get all of them. Okay, so you can have the full view, the stack layer of that specific link. Now it's another option. I'm just showing you, but it's a pretty bad, let's say, use of it. It's a free text search. Okay, you don't really know what you're looking for. You know that you have a link and something with Stockholm inside. So by filtering with a free text search, it will bring any link that anywhere in its attribute you have that string. Okay, but don't use it because you're going to have a lot of different objects, and probably most of them will not be relevant to you. Okay, so it is a bad practice, guys. Now, the time-based queries. Why do we need it? Whatever Daniel was showing us. So let's say that customer was complaining that during the weekend he had a bad service, a bad SLA, long delays, service down. So you can take your network to the past snapshot and check whatever was there. Or let's say that you had a problem, you fix it, but the customers today, again, complaining that even after you fix, the SLA is pretty bad. So you can take yourself back in time before the problem to see maybe your LSP was reversing a different way. And now after you fix the problem, it was not taking back the optimized route. Okay? So for using the time machine, the key here is the @ sign. We can have absolute time, you see date and time, or we have the relative format, minus and then number of years, month, days, minutes, seconds, and so on. In this case, it will be like 10 hours back. Okay. Also, we can have the Unix timestamp. Okay, so in this example, we are asking for all links with opera status down that were 40 days ago. Okay, so again, remember that, and later on you think that you'll find many ways to use it in your organization. Just to explain a little bit about the time machine, how it's possible. Every change is being stored in the database, meaning if a link went down, we are not updating the link object, but we are putting a new entry in the database with the specific GUID, the current state, and a timestamp. Okay, so by using it that way, when we are asking a specific time, the whole system knows to bring you the required timestamp of the database and show you the state and the topology of the network back then. Now another thing that we can also use the add, delete, and update action types. Let's say that I know that something was bad during the weekend in my network, but I don't know exactly what had happened, and I don't know exactly when. Okay, so using the history as a history application as Daniel was showing, I can ask in this way: bring me in the last week all the links pipe history that the action was update. Okay, we can ask action update and opera status change to down, and that will bring you all the changes. Okay, in that case, it will be much easier for you to troubleshoot because now you know exactly which link went down and exactly when it was down. We also support many different functions. So with these functions, you can also organize the response the way you like. You can sort it, you can limit, you can have a kind of summary counters, and declare yourself a view. So this example, we are asking all routers that name end with Valencia, but bring me it in ascending order of the name. See, so we'll have all the routers that ends with Valencia in a ascending order. Okay, same we can have with descending. Now let's say that you don't want the full response. You want just to see an example of the LSPs that you have somewhere. So you can ask, bring me all LSPs, but only the first 10. You can limit the size of the response. Okay? In this case, we are asking counters of the responses, meaning, this is good for dashboards, for executive summaries, and so on. So what we are asking here is bring me all links. Please use the counters by opera status and layer, but limit zero. What means limit zero? I don't really care about the objects themselves, only by the counters. Okay, so here you can see that we have, okay, opera status down, we have 43. Layer ZRP media, we have 84, and so on. Guys, you are the quietest audience I ever had. Okay. Coffee on me later after this session. No, you cannot specify an offset. Right. So let me emphasize what Moti is saying. I'm not going to show you all the different options and features that the language itself is supporting. Okay, we have pretty good documentation for that. Here I'm showing you just the highlights for you to start kind of triggering your imagination of what you can do with that language. Okay, and you can see actually that it's a very intuitive one, meaning you don't really have to know SQL to work with it, right? Let your DBA's expert to do more interesting things, right? So in this case, I want to show you how to create a view. We saw that each type, each object might have tons of different attributes, but I'm not interested in all these attributes. I just want to see, please bring me all physical ports and let's create a view. So an attribute called name or column called name, it will be filled with values from the attribute of the object .name. Description will be from .desk, site name from device site name, and so on. So eventually you will not have a table with, I don't know, 20, 30 different attributes, but only what you need. Again, so you'll have a pretty much smaller response. It will be much easier for you to parse only what you need, only what you expect to get. Now let's go to a different section of the application of HCO that again can be queried by SHQL. The tags. You remember that Daniel was showing you that by tags you can ask for, by the examples, bring me only Cisco network, bring me only Sienna network, bring me only routers in France, and so on. So how to do it? We are going, bring me all inventory dot tags, where you have a tag called vendor, and the vendor has the value of Cisco. So actually how it works, also the tags are being declared by SHQL. Okay, and there is a process that every period of X time, it calculates automatically and dynamically all the objects that respond to the query that you put, to the rule that you put, and tag them. Meaning that if you create a new link and he responds to a specific tag, you will be automatically tagged with that. You don't have to go and start tagging all your objects. Okay, it's a dynamic tagging system. And here you can also use it through SHQL. Now, how to use regions. In this environment, I added the regions as countries in Europe. I was looking a GeoJSON file of countries in Europe. You, as our customers, can choose a different way. You want all the counties in England. You want all the different regions inside Sweden. Or if you have a specific division of your network, you can create your own GeoJSON file and load it. And then, by this example, please bring me, start with region Israel, bring me all sites that we have in Israel. Okay? So automatically, when we are creating, loading regions, a process under the hoods calculating which sites belongs to that. And another example, if we already have, I think that I have your example. Yes. So you see, bring me all sites in Israel. From the site itself, bring me all inventory item tagged vendor Cisco, but I don't want all, the routers itself. So within that, bring me only the physical ports. So eventually the response will be the physical ports of Cisco routers in Israel. Okay, we start having more complex queries, right? And again, it's pretty easy, pretty intuitive, and you don't have to know SQL. Events. HCO holds events, internal events of all kind of different usage type, usage of different application, different processes, authentication, let's say who was trying to authenticate and failed, who was successfully logged in, and so on. So we can query that. In this case, you can see that I'm asking here, bring me all events severity usage in the last 2 weeks, grouped by username and type. So we can see that username, in this case, all were admin, but some of them are the 3D map, some of them are of the SHQL query application, the root cause analysis application, and so on. So in that case, you can monitor the usage of once of the usage of HCO and also different changes in your network. Another example is bring me all events that the data contains SHQL. And again, you can see that here have been queries, edit new queries, and so on. Okay, so again, you can detect exactly what was done, who was using, who was doing what, and when. Now let's take example of a few even more complex. And again, these examples only to kind of tickle you to understand what you can do. So probably whatever you want to do or get information regarding your network probably can be done. So this query will show all physical Ethernet ports that are used by links in a site. So how I do it? Bring me site name contains Milan. There, bring me all inventory items and port of physical type, links, and from these links I need only the ports. So eventually we'll get all the physical ports in Milan, and you can see that some of them are some of them are ports in routers, and these Ethernet ports are in optics that are the Ethernet ports that connected to the routers themselves. Okay. Another example is show me LSP, specific LSP down, all LSP in Lisbon that are down due to a OCH link failure. How I'm doing that? So I'm starting with link, layer LSP, and port A device site name Lisabon, or port B device site name Lisabon, go downward and bring me downwards only links OCH that they will per status down. So in one query, we found the root cause of an LSP down, right? Root cause analysis through SHQL in one simple query. Any questions by now? Good. So now we'll go to a demo. We'll show you how it can be consumed through REST API, through HCO, CLI, through NSO-NED, and also some example in SHQL application. Any questions by now? Well, everything is clear? Good. Daniel?
Thank you, Yona. So I hope you feel like a real SHQL hero now. That's still sharing. Let me stop the presentation. Right. So we talked about the what. So what is the hierarchical controller and kind of why we want to do things like that for root cause analysis and going back in time and having like an ultimate view of the network. But sometimes we maybe don't want to do this in HCO as the SQL application or whatever, because you want that data fed into another system or you want to query it from another system. So how can you leverage the power of SHQL from outside? And as we already mentioned during the session, so there is an endpoint for the query. So you could just actually put it in the browser, right? So I'm just querying here the database for all IGP links, but I'm limiting it to one because otherwise the browser would get flooded. So this returns me the JSON object here, right? But we can use the same query within Postman. So, oops. We just pointed towards the endpoint, and then, as Jonas said, it's just a raw body, right, where we define the query inside, and I want to see that. So I want to see the reply here. So basically, same query, same reply. That's just an example query that doesn't overwhelm. So you can integrate this with the with any application that is able to post queries against the API endpoint. But there's also other means. For example, and John, I have to correct you here. It was not me writing the net. It was the fantastic team of Frida who provided that net.
I'm sorry.
So you need to make sure about two things here.
Presenting.
Oh. Oops. This thing does not like me. So when you use the NSO-NET, you basically need to make... Now. So we'll have a quick look at the the net itself. It's called Cisco CHC show pack. Version 114 is the one that we need. Anything before 114 will use or will assume a RESTconf server being present on HCO. That is a legacy add-on on top of HCO that doesn't exist anymore. So we had to change the net, or Frida's team was doing that to use REST instead of RESTconf. So if you want to use the net, you need to have version 1.14, and then basically you just need to tell NSO in the device that you create for CHC devices, device CHC, and then let's do deselect. You just basically need to tell it that it should use REST only, and you point it towards the URL base, and then you're good to go. The net right now supports two main things. One is obviously using queries using the live status API, so you can directly access it from NSO. But that's more a run use case. When we're not going to touch about that. You can sync from the device and get all the cross connects that are defined in HCO, meaning the optical to the mapping of an optical pluggable to within the router to the DWDM system. So you can do the invert here and look at the just the config, and then we will see that that's basically what we're syncing from the device, the optical cross connects here. Yes. Oh, okay. What? Okay. Right then. Let's wrap it up. There was one more example, CLI, but let's not do that. So what we have been talking about here as the HCO as the network, as the API to a network, is obviously based a lot on read-only, right? A query language by definition is read-only. So we haven't really shown any like write to your network examples, like provisioning. But that has a reason, because it's currently not supported in HCO 7. It comes in HCO 8. Then we will have the service manager app, which is an application within HCO, also will expose its own API, and then you can leverage another API to actually do provisioning of services or whatever the service manager app will let you provision. So hopefully we will be able to show that next year, or when's HCO 8 due?
8 due to October or November this year.
Oh, yeah. Maybe if we get to New York, we can do it in New York. Yeah, so New York or later this year in New York, or maybe next year. And if you want to get your hands dirty with HCO and you don't have it yet, then we do have a dcloud lab. So if you want to play with it, make sure to book a dcloud lab and give it a go. And with that, I think Jonna and I just want to say thank you.
Yep.